Okay, with the first index law, we will be looking at what happens to powers to index numbers when we multiply the same base number. So before we look into that, we'll just cover a few basic terms. If I have the number 2, just say there is actually an invisible power, and that is the invisible power 1. Just like we know that 2 is really on top of an invisible 1, but we obviously don't write our 2 like this because it takes up a lot of space. Now, I'm going to do my 2 again, and this time the power, I'm going to make it a 3. So it's now 2 to the power of 3. Now, this 2 down here is called the base, or base number. And if I used a variable, if I used just say a instead, a would also be called the base. So imagine that a, instead of a, I had a 2, and instead of 2 I had an 8. And I also will put it to the power of 3. So the same thing, but in this case we've got an a, in this case our base is a 2. Now the power which is sitting on top, and it's smaller, that is called the index number. And this actually has more than one name, but at this stage we'll be using index number. We can say index numbers for plural, for more than one, but the proper way of saying it is indices. So indices means more than one index number. Or you can just really say index numbers, that's fine. They're also called, we can refer to them as powers, which I think we are more familiar with. They're also called powers. And later on, we will call them exponents, or an exponent, which is 1. So just a few key terms that you have to become familiar with. So this can be called the index number for more than one, the indices, or we can call it power or powers or exponent. Okay, now I'll just clear that. So with 2 to the power of 3, we have learnt that it's simply saying 2 times 2 times 2 3 times. And 2 times 2 times 2 3 times will give us an 8. So we can work out what our answer will be. So 2 to the power of 3 is actually the number 8. Now, if I started off with 2 times 2 times 2, and I asked you to simplify this, not to work it out, but to simplify, well, this is where you would have to remember that there's an invisible power 1 above all the 2's, and I've made them visible because we now have to add them. And that is the first index law. Whenever we are multiplying the same number or the same base, okay, so this base down here, I'm going to have a times 8 instead of 2, okay, but we do the exact same thing. There is an invisible 1 above the a also, and we will be adding their powers as well. So back to this one, we've got 1 plus 1 plus 1, which is just going to be 3. The base number stays the same, but it is now 2 to the power of 3, and I have simplified it. Okay, it's just the same thing on top. Up here, what we did was we expanded, so we went 2 times 2 times 2, whereas down here we have now simplified. So, and we know simplify means to make more simple, and it's taking up less space, I guess. But it still equals 8. Down here, with this example, I do the same thing. My base, which instead of 2, it's an a, I have 1 plus 1 plus 1. Remember, we add the powers, and that becomes a to the power of 3. And I stop there because I don't know what a is. I can't get a number because I haven't been told what a is. So that is the first index law, which is simply whenever we are multiplying, okay, you have to check and see what the operation is. We had multiplication everywhere. And it's very important. So when we are multiplying and we have the same number or the same base, in this case here, instead of a number, we have a variable, we have to add their powers, only of the same base number. And just remember that we don't have a plus a plus a. That's totally different. If we had a plus a plus a, it is saying 1a plus 1a plus 1a would give us a 3 still, but it's a whole number 3, and we end up with 3a. So if you've forgotten a bit of your algebra skills, go back and look at the other lessons on some revision. But just remember, our operation in between the variables here is multiplication, not addition. Two different things. Now let's look at another example. What if I have something like this? We've got A times B and times C. So with this one, we can see that yes, we will be simply multiplying all these variables and our multiplication symbol will become invisible. However, we notice that we've got the same variable, the same base here, A and A. So we have to add their powers. Okay, so 1 plus 1 would leave me with a 2. So I would end up with A squared, or A to the power of 2. B and C, I can't add their powers because they're different base numbers. So I'm left with B and C. And we know that there is an invisible times in here, and that will be our final answer. So remember, only adding the powers of the same variable, same base. We'll try another example. Let's try x to the power of 3 times x to the power of 5. So with this one, we can see that the index numbers, the indices, are not invisible. And once again, check that we have the same base. Yep, x and x are the same, so my base won't be changing. X will be staying the same. What will be changing are the index numbers. So 3 plus 5 is 8, and that would be my final answer. Same with numbers. For example, instead of an x, what if I had 2 to the power of 3 times 2 to the power of 2? So we can do the exact same thing. Because I have the same base, 2 and 2, I simply add the powers of 2, so my base number 2 will stay the same, and 3 plus 2 will leave me with a 5, and I'm left with 2 to the power of 5. Now, because I don't have an unknown variable, I can see my number is 2, I can work out or evaluate what is 2 to the power of 5, and that is simply saying 2 times 2 times 2 5 times, and we'll be left with 32. You just chuck that in your calculator if you wanted to, but it's saying 2 times 2 times 2 times 2 5 times. Now, if we worked it out a different way, if we went, okay, let's just make sure we're doing the right thing. 2 to the power of 3, I know is 8. I've got times there, and 2 to the power of 2, I know is 4. Okay, just to make sure that adding index numbers is giving us the same answer. Now, 8 times 4, I know is 32. So we can see that by adding powers and simplifying, we still get the same results, which is why it works, and that we can see that it's an accurate thing that we're doing. So let's try a more trickier example. Let's see, if I've got a to the power of 3 and b to the power of, oops, sorry, I'll just clear that. Start again. If I've got a to the power of 3 and b to the power of 2, and I'll chuck a c there, times a to the power of 7 and b to the power of 8 and c. Once again, if this confuses you, just remember that there is actually times in between everything. Okay, there's invisible times everywhere. It's just that sometimes we don't have to write it, and it's better for us not to write it because it takes up less space. So work with one thing at a time. Check, because I have my a to the a cubed first, a to the power of 3 first, well, I'm going to work with my a. Do I have an a on this side? Yes, I do. So my base stays the same. It doesn't change. All I am doing is adding 3 and 7, because remember, our operation is multiplication. So 3 plus 7 leaves me with a 10. And if this helps, cross it off, because we have worked with our a's and we've got our answer for that one. Next, b. I have b squared here and b to the power of 8 here. So once again, my base b will be staying the same, but I have to add 2 plus 8, and 2 plus 8 is just 10 also, and that's gone. And last of all, I've got a c on this side and also a c there, so it's to the power of 1. I know that's invisible, and I have to add those 1. So 1 plus 1 is 2, so I'm left with c squared, or c to the power of 2, and there is nothing else I can do. And that's it. We'll try a couple more. Now, what happens if we have, let's see, 2, we'll do a cubed, and b to the power of 5, chuck a c there, times, now what happens if I've got a 6? Alright, now, when we have numbers, and we can see that 2 and 6 are not the same base number, so I'm not going to be adding their powers, but even if I did have the same number, like a 2 here and a 2 here, you can add their powers, but a shortcut is just multiply them. So whenever we have numbers on both sides, like here we've got 2 times 6, I know that 2 times 6 normally is just 12, and that's it. So remember, whenever we see actual whole numbers, we just multiply them as normally. And that's gone. And now once again, I've got a to the power of 3 and a to the power of 10. So there's an a on both sides. So I've got 3 plus 10 is 13. Just add the powers of a. Next, b to the power of 5 and b to the power of 2. So once again, add the powers of b. 5 plus 2 is 7. Now, with my c, I look on the other side, there is no c there. So there's nothing for me to add in terms of the powers. So the c is just stuck there, and that's it. And remember, there's times in between everything, so we have simplified this, and it looks a lot more simple. So just to revise and recap, the first index law, all we have to do is add the powers of the same base when we see this operation here, when we are multiplying. It's very important that we are multiplying. So always check what operation you have, and then add the powers of the same base. Okay, actually we'll do one last question, and I'll chuck in some negative numbers. So last question, I'll put a -3, -2. All right, so with this one, we do the exact same thing. It's only trickier because we've got negative numbers. So the only thing that will be holding you back is if you are lacking skills when it comes to negative numbers. So you have to make sure you go and revise that. Now, once again, 2 times 4 is simply 8. That's easy. Multiply my numbers. I know that now. Now, I have here a to the power of a -3 and a to the power of 5. I'm still adding these powers. So if I did it the long way down here, I will have -3 plus, because remember we add the powers when we multiply, a +5. It helps to write it out, and you can just chuck this in your calculator. And I'll do the same for b. So I'm going to put my b next, and I've got a -2, so plus, add the powers, 10. And that helps me because now I can visually see what I am calculating. So my base numbers, I'll have a and b remaining there. But with my a, I have -3 plus 5. Well, -3 plus 5 is a +2. And over here, I've got -2 plus a 10. And -2 plus 10 leaves me with a +8. So when you do have negative numbers, you just simply add them as normally. And if you do get stuck, use your calculator to help you. Thank you.